And welcome back. So we ended with these final examples for you to look at before you started. Hopefully you did. Maybe you didn't. In any event, let's talk through them real quick. So the first one here is asking 2 raised to what power gives me 8? And the answer there is 3. 2 to the third power. Next one, 8 raised to what power gives me 1? Well, just about anything to the 0 power is 1. So I bet you log base 8 of 1 is 0. Next up is something we basically already did. 5 to the power of negative 2 gives me 1 over 25. Then we're looking at 6 raised to what power gives me 6? Well, I guess that's 1. And then finally, and this is going to sound a little silly, 12, that's my base, raised to what power gives me 12 to the 37th power? Well, I guess 12 to the power of 37 is 12 to the 37th. So that's what we got there. Hope you got them all. There's just a little bit left to say here, so we'll go ahead and say it. There's a couple of big bases out there. Some bases are more equal than others, a little more important, right? We got 10 fingers, we got 10 toes, all of our numbers are in the base 10. So, well, not all of them, but the numbers we most commonly use are base 10. So the common logarithm for us is base 10. So if you're looking at a logarithm and it's just log x, then you're to understand that to mean log base 10 of x. Similarly, the natural logarithm is base e, right? We don't have e fingers and e toes, but we do deal with finances and we deal with population growth, and a lot of those use e as their base. In fact, the continuously compounding interest formula had base e. So the natural logarithm is something we don't need to shy away from either. And so whenever you see ln, that's log natural logarithm, and that's log base e of x. Of course, ln is a lot easier to see than log. Not as fun to say, but that's why we write it the way we do. And that's just something you're going to want to commit to memory. No base, that's base 10. ln, that's base e. And we care about these bases for 2 reasons. First of all, they come up all the time in different formulas. And also, we as students care because those are the ones that our calculators can crunch the easiest. So let me pull up my calculator here. And I need to crunch. Yeah, you like how I'm doing this? Oh, I ruined it. I need to crunch the log of 72. So 72 log. Boom. And I just got it. In fact, stop ruining it. That is what we've got here. The natural log of 238. 238, natural log. Obviously, I'm going to have a lot more decimal places than I'm willing to write. In fact, this decimal expansion does go on forever, so eventually you're going to have to round. Right? You want to do the logarithm, not natural, but common of 2020.3. There you go. And if you want to do the natural logarithm of, I guess that's about pi, you could just press the pi button if you've got one and take the natural log of that, and you're going to get we'll call it 145. That's all you have to do. Now, if you don't have the natural logarithm or the common logarithm, and you've got a pretty dumb calculator that can only do one of those 2 things, you can use the change of base formula. I don't really stress this much personally. It's a couple of the questions on your assignments here. So if you need to use the change of base formula, here it is. Basically, you can take any base and rewrite it as a quotient of your new base divided by the log of the old base. And that can be a common log, it can be a natural log, it can be any base you want, preferably one of those 2. And it doesn't matter what you use so long as you're consistent. And that's it. So I hope that worked out for you guys. Let me know if you have any questions by next time. And don't forget your assignments are posted to WebAssign. You need to spend at least 45 minutes on this 10.1 stuff. And you just let me know how it goes. I'll see you in the next one.